All right, so we're now going to take all this information that we learned today and didn't just learn, but remind ourselves from grade 11. We're going to take related acute angles, casserole, exact values, special triangles, and coterminal angles, and put it all together to find exact values of these much bigger ones. And so again, we're going to work smarter here instead of harder, and use all the rules to help our question look much easier. So we're going to look at sine 420. We want to find the exact value for this. Again, we don't want to punch that into our calculator. We want to be precise. And so we should be able to do this without a calculator. So first thing I got to figure out is which quadrant 420 is. And I could give you a second just to talk to your elbow partner and figure out what quadrant 420 is in. So after some talk, hopefully we all agree that 420 degrees actually ends up in the first quadrant. So why is that? Well, just off to the side, I might do this in my head. 420 minus 360 is 60 degrees. So I think about it, and this is a full rotation of 360 plus an extra 60 degrees to get to my point. So there's 420 degrees. So the good news is 420 degrees and the 60 degrees that it actually stops at, the ratios are exactly the same because you have the same terminal arm. So we can first change these big ones into a coterminal angle. So the first thing I'll do is just say, hey, this is the same as sine of 60. And this is a coterminal angle. Now I can go off and answer this just like the other ones. Well, guess what? Sine 60 is actually one of my special triangles. So I can go back, look at my special triangles. Where are they? There they are. So sine 60 is opposite over hypotenuse, so that's root 3 over 2. And so I know sine 60 is root 3 over 2. So the sine of 420 is the exact same as the coterminal angle of sine of 60, so why not just use that right away? And it's root 3 over 2. Again, you can punch that in your calculator, say root 3 over 2, get some decimal answer, and you'll find out that that's the same answer as if you put sine 60 in, or sine of 420. You'll get that same decimal answer 3 times. But I can do this without my calculator, and it's more precise. So now I can look at something like the secant of 405. So now this is taking everything. So again, I'm going to draw a picture. Think for a second 405 is bigger than 360, so I'm going to subtract 360 and say that that's 45. So that means I must go a full rotation and then go 45 more. So 45 is a coterminal angle. This is 405. So before I even consider what quadrant I'm in or anything like that, I know that the secant of 45 is going to be the same as the secant of 405. Now I'm going to stop and think and say, okay, secant is the reciprocal of cos. So I'm going to think for a moment, what's the cos of 45? Well, again, using my special triangles, I know that's 1 over root 2. So this is 1 over root 2. So the reciprocal I want is going to be root 2 over 1 or just root 2. Now, of course, we could have a situation like this where the terminal arm's not going to be in the first quadrant, and we have to consider the cast rule as well. So this one is like one of my favorite questions because it has everything in it. So let's think of 495 degrees. Okay, well that's pretty big. So 495 again is bigger than 360, so I'm going to subtract 360 and get 135. So that must mean I go a full rotation, 360 degrees, and then still have to go 135 degrees, which is way over here, to get my spot. So I know right away that this is the same as tan 135. So don't bother dealing with tan of 495. Find the coterminal angle first, and it'll make my question a lot easier. Now, I got to look at 135. Well, guess what? 135 is not one of my special triangles. So I don't know the tan of 135, but I do know that I could figure out the related acute angle, but just recognize which quadrant I'm in. So I'm going to look at this and say I'm in this quadrant. This is the CAST, so I'm in the S quadrant, which means my answer is going to be negative first, and it's going to be equal to the negative tan of the related acute angle. Well, if I've got 135, that must mean that this is 45. So the related acute angle is 45. I got that from 180 minus 135. So just like the questions we just looked at, the CAST rule gets me my sine, and a related acute angle gets my angle. And guess what? 45 right now is one of my special triangles. The tan of 45 is opposite over hypotenuse, so that's 1 over 1, or just negative 1. Okay? So again, these rotations are really, really helpful. All right, so the next one we're going to look at is this cos negative 630. So this is very interesting. So first off, it's negative, so we're going to have to remember to, when we draw our picture, to draw it going in the opposite direction. Also, we're going to want to, sorry, let me just extend the page here to make it longer. Okay, so negative 630 degrees. Well, that's definitely bigger than a single rotation. So I'm going to take 630 and minus 360. And that's going to be 0 and 13, so 7 and 2, so 270 degrees. Okay, so, but remember I'm going in the negative direction. So I'm going to have to go like this, and I have to go negative 360 degrees, then plus another 270 degrees, which is very unique because I end up right at that spot at the top. So I'm going to deal with that in a second. First, I'm just going to say this is the same as cos negative 270. There is one coterminal angle. But even negative 270 doesn't sound right. So I'm going to consider a different terminal angle, a second terminal angle, and say, why don't I just go straight there using the positive one? And say, isn't this going to be the same as cos of 90 degrees? Because if I just go in the positive direction, I'll end up at the same spot at 90. So now it's a little bit easier to use cos of 90. The only catch is 90 degrees is not one of my special triangles, but I should still know what it is. And you can double check this if you want in your calculator, just punch in cos of 90. But frankly, we also need to remember how the cosine curve looks.
Miss Francis, contact the office, please. Miss Francis.
So there's the cosine curve, starting at 0, finishing at 360 degrees. Halfway is 180. And halfway between those two, right there, boom, is 90 degrees. And cosine must be 0. So it turns out the answer to this is plain old 0. Not positive or negative, it's just exactly 0. Now we're going to look more at these types, the ones that land on like 90 degrees or 180 or 270 or 360. All of those, we just need to understand where they come from, and the picture helps us understand that. And so you may have seen when I was fumbling around this fifth one, but again, we're going to save that for when we are together. So Here's a bunch of questions that you can practice, and I'll ask the supply teacher to just pause the video here so that the teachers can, or the students can copy it down, and then we will take this up next time we're together. Good luck.